Hi everyone. In this video, we are going to discuss how to measure power and energy in different power factors in single-phase circuits. Objective: at the end of this video, you'll be able to measure the power, energy, and lagging power factor in single-phase AC circuits, measure the power, energy, and leading power factor in single-phase AC circuits, compare the characteristics graphically. Before entering the practical session, let us discuss the power factor. What is power factor? Power factor is the measure of how the incoming power is used efficiently by an electrical system. A high power factor shows that the power supplied to the electrical system is effectively used. A low power factor shows that power supplied to the electrical system is not effectively used, resulting in losses. We all know that there are two types of electrical power: alternating current AC, direct current DC. In AC circuits, the value of the power factor always lies between 0 and 1. But there is no power factor involved in DC circuits because there is no frequency. The cosine of the angle between voltage and current is referred to as the power factor. The phase difference between voltage and current in AC circuits should ideally be 0. However, practically speaking, there is some phase separation between the two. The power factor is the sign of the phase difference between the two. Type of power in AC circuits. There are three types of power that usually occur in the AC circuits. 1. Apparent power, denoted by S. Formula is S equal to V into I, and unit is volt ampere VA. 2. Real power or true power or active power, denoted by P. Formula is P is equal to V into I cos pi. Unit is watt. 3. Reactive power, denoted by Q. Formula Q is equal to V into I sin pi. Volt ampere reactive VAR. Let us consider an electrical circuit. Here you could see an electrical circuit consisting of an input power supply and a load. The power that is transferred from the input power supply is called apparent power, and the power utilized by the load is called real power, true power, or active power. When electrical power in an AC system flows to a load, not all of the power is absorbed by the load. Some power may be wasted or reflected back due to the nature of the load. This reflected power is called reactive power. Power triangle. The power triangle is the representation triangle showing the relation between active power, reactive power, and apparent power. From the power triangle shown above the power, the factor may be determined by taking the ratio of true power to the apparent power. Power factor cos pi is equal to active power upon apparent power equal to kW upon kVA. Let us discuss with an example. Example 1. In the image, you could see the cup of coffee filled with froth. Here, the coffee drink content is analogous to real power. The froth that appears at the top of the coffee is analogous to reactive power, and the total content of the cup with coffee and froth is analogous to apparent power. Example 2. In the same way, you can also understand the apparent, real and reactive power of a cup of Coke as shown in the image. Example 3. Here you could see the chip bag analogy of apparent power, true or real power, and reactive power. Type of power factors. There are three types of power factors. 1. Unity power factor. 2. Lagging power factor. 3. Leading power factor. 1. Unity power factor. Unity power factor is the one where both voltage and current signals travel in the same path. This shows there is no phase difference in unity power factor. In this case, the maximum power is utilized by the load without any losses. Hence, the power factor is 1. Hence, it is called the unity power factor. Simply, at the unity power factor, the whole part of the main power supply is doing the useful work. In this case, no power is wasted. When unity power factor will occur? In a DC circuit, the power factor is always 1 or unity due to no phase difference. In the case of the AC circuit, the unity power factor occurs when a purely resistive load is connected to the supply. Unity power factor will occur at resistive loads like incandescent lamps, electric heaters, electric irons, etc. The pure resistive circuit draws the current which is in phase with the applied voltage. The voltage and current are in phase in the resistive circuit. Thank you for watching. Have a wonderful day.